Okay. So 10-1, circles and circumference. First thing, just make a circle. And we're going to label a few parts on our circle. So remember, wherever you want your circle to be, that's where the point on your compass goes. However far you have those arms spread apart, that's how big the radius is going to be. And then there's a few different ways you can do it. What I like to do is just kind of hold the compass up there at the top with one hand and usually 2 fingers and my thumb, and then just kind of pivot around to make it. If that's really hard and not working for you, another option is you could press down and then just literally turn your page around. Or you can try some kind of two-handed method. Just kind of figure out whatever works for you. There's not a right or a wrong way to do it. Just make sure you keep the center where it's at. Try to turn it in. And if you would, just kind of make a mark where your center of your circle is. So just make a point there. And then just label that as the center. Every circle's got one. It's kind of an easy way to identify the circle. So easy that we use the center to name the circle. So just so we're all on the same page, go ahead and make your center point F on the circle you just made for. Circles are probably the absolute easiest shape that we've ever had to name, because all you have to do is look at the center, you use that to name it. So we will call this circle, circle. Yeah. So you can write it, or we can use a symbol. And what do you think the symbol for circle is going to be?
Circle.
Yeah, good job. It's a little bit more specific. Instead of just using a circle, you do put a dot in the middle of it. You think of some reasons why we might want to do that instead of just using a circle. Yeah, so that way it doesn't look like 0 or O. It's the center, so that way you know it's a circle. So you don't think it's an O or a 0. So when you make the circle symbol, put a dot for the center. So that's how you name them. Look at the center. That's the name of the circle. Some vocab terms, which I'm sure you probably actually already know. First one, radius. We've used this term this year, just kind of formally defining it right now. This is a vocab word I'll expect to know for the test. On a circle, the radius is the segment whose endpoints are the center of a circle and a point on the circle. That's got to be specifically that. One point's on the center, the other point's actually on the circle somewhere. And a circle could have an infinite number of radii. What do you think radii is? Yeah, you don't say radiuses. It's called radii. Kind of like when we had rhombus, what was our plural? Rhombi, same kind of deal. So when I say radii, it means more than one radius. So from center to a point. In fact, it's going to be true. All the radii on a given circle will always be equal. So it doesn't matter. Next term. This one you might not have had before. It's called a chord. Does that word sound familiar at all, or is that something new? Okay. Easy one. It's a segment whose endpoints are on the circle. So any segment that you draw and its two endpoints are actually on the circle, it's a chord. What's the other segment that you probably already know about? What's that? Okay, here are two things that are good. It's all the way across, so that means it has both endpoints on the circle, so that makes it a chord, and it goes through the center. So a diameter is a chord that contains the center. It goes all the way through, and it has to go through the middle. And then what Grayson says is also true. If you put two radii together, that's always going to be a diameter. Okay, so those are three terms that you should know and be able to recognize pretty easily. So what's going to be up here next is going to be figure, and I'm just going to have you name something. Excuse me, name some things. You don't have to write this down. I think you're going to have it like that. So again, you don't have to make this. Just look at it. That yellow line that just popped up, which would it be? Why? Doesn't go through the center, but it's got two endpoints there. So just a chord. Why is it a diameter? So what is it also? So that's a diameter and a chord. It's most specifically diameter, but it still counts as a chord. And you can guess what this last one's going to be, the green line. Why?
Because that starts at the center.
Yeah, starts at the center, goes to the circle. So it's a radius. And then also, what you all next said is true, which is actually our next point. Some formulas which are really easy to work with, and you actually sound like you already know them, is how to go from radius to diameter. And we care about that because when we're figuring out certain things with a circle, we might only care about what the radius is. Really easy calculation, though. You don't need to make the circle. I think you're okay with just looking at it. We could say the radius equals half the diameter, or if I wanted to go the other way, the diameter equals 2 times the radius. So it's really easy to bounce back and forth between those. You've got the radius, you want the diameter, double it. You got the diameter, you want the radius, and half. Okay. Make sure you know that rule. Play this up and do what you're right. Kind of tying this into what we did a couple chapters ago. Since all circles have the same shape, they are all similar. Remind us what it meant for two figures to be similar. Okay, so I'm hearing a few things are all good. Same shape, but not necessarily the same size. Now you think about it, a circle is a circle. You can't really make it different at all. So it's always going to be proportional, so therefore they're always similar. So it's impossible to make two circles that aren't similar. They will always be. Two circles are congruent if their radii are congruent. It's really easy to check to see if two circles are the same size or not. All you have to do is look at their radii. If each one has the same measure for its radius, then they are congruent circles. You don't have to look at any other measure. Just the radii are enough. And here's a new term. Two circles are concentric if they, as you're writing that, before I give you this definition, put some thought into what you think that word means, just by looking at it. Pretty sure you can probably figure it out. So I don't want to hear it yet. I want everybody to think about it for a little bit. But just look at the word, try to take a stab at what it means. What are you thinking? Same center. How'd you figure that out? Yeah, like that prefix co, when we see that, usually means same, like, what's another geometry term we've had that started with co? Co what? Yeah, what that mean? Anybody help me out? What's it mean? Yeah, on the same line. I think you said coplanar, so on the same plane. So concentric, same center. That's part of it. So the first part, they have the same center. And that's not quite enough, because as we kind of looked at last time, we're kind of branching out a little bit. We're not just looking at flat stuff anymore. We do have some 3D things going on. So we are going to say they lie in the same plane. They have to be on the same flat surface. So what wouldn't count, kind of look up here and try to visualize what I'm showing. Let's say that I drew a circle just kind of around like this, okay? So I got a circle in the air, I can hold it like this. And I drew another circle going this way. And I could put those together so you kind of imagine like two discs, one laying flat, one's this way. They could have the same center, but they're not concentric because they're not laying on top of each other. So that's another requirement. They both have to be flat on top of each other. And then the last thing, they have radii of different lengths. They have radii of different lengths. Why do you think I made that distinction? Yeah, that would mean it. Because if they had the same center and the same radius, they're the same circle. So what these could look like, and I'm sure you already kind of visualized it, is, let's say I have one circle like this. That's its center. Well, I could have another circle around it like that that's got the same center. You can see really easily the radii are different. They're both on the board, so they're on the same plane, and they do share the same center. So those would count as concentric. Another term that I know you all know about already is circumference. And that is the distance around the circle. And we've got two different formulas that let us find circumference. Yeah, I guess my shirt's kind of fitting for what we're talking about today. We had C equals pi times diameter, and C equals 2 pi r. Why are those formulas the exact same thing? Yeah, what both of you saying is true. 2 radius, the 2r, well, that's the same thing as d. So it doesn't really matter which one you use. And you don't even really have to commit them both to memory because they are the same thing. And this, I do kind of want to look at like a little proof for where this comes from. Ultimately, what it turns into, circles or rectangles. So let's say I make a circle, and this you can just look at. You don't necessarily have to copy down. Let's say I make a circle, and I cut that circle into a whole bunch of little sectors. So let's say I go there. Now it's in halves. Now it's in fourths. Now it's an eighths. Let's say I go again. Yep, so now it's going to be in 16ths. And let's say I took those pieces out and I lined them up. What I would end up with, and I'm not going to draw it all, but here's a piece, there'd be another piece next to it, and then that would just kind of keep going. What's going to happen is, this was from the center to the circle. So what is that? So that's the radius. And what this is, from here out to here, would be half the circumference. So instead of 2 pi r, it would just be it would just be pi r. And that's something we'll use a little bit. So kind of keep that in mind. We could change it into a rectangle if we wanted to. Now, I only cut it up into 16ths, which really isn't that much. Using calculus, we could actually cut it up into an infinite number of parts, and then it wouldn't be slanted. It would be a perfect rectangle. And that's how we're going to get our next formula. So just kind of keep in mind, as far as pi, what that is, it's the ratio between the circumference and the diameter. So if you make any circle, and you measure the circumference, so maybe lay a piece of string out around it, measure your string, then measure your diameter and divide, you're always going to get pi. And that's how people first figured that out. They knew that that was a pretty important number, and they got better in calculating it, and now we've got it as far as we'd ever need it. But that's where that comes from. And our last two terms for this first section, inscribed and circumscribed. They're kind of like opposites. If you got one, you're always going to have the other one. Yes. It's pretty short too, though. We are not even halfway through class, so we're good. A polygon is inscribed in a circle if all its vertices lie on the circle. So what that means is basically you've got some polygon inside the circle, and in addition to that, its points are touching the circle everywhere. So that could be like if I make a circle here, and let's say I put a square on the inside. A really terrible looking square, but a square. I could say that that square is inscribed in the circle. It's on the inside of it, and every point on the square is on the